multi-threading 101. Today we are going to solve override problem. And the problem goes like this. So there's a political conference going on, and there are two parties, Republicans and Democrats, are trying to leave the venue and post that they are trying to book a Uber cab at the same time. However, we wanted to make sure that there shouldn't be any fight between them and everything should go smoothly. So in order to achieve that, there are certain conditions which should be followed in order to avoid the fights. The first condition is either all the Democrats can live in a single cab, or all the Republicans can go in a single cab, or two Democrats and two Republicans can go in a single cab. Apart from this, all the other combination can result in a fight, right? So our task as a developer is to model the ride requesters as thread. And once an acceptable combination of riders is possible, then threads are allowed to proceed the ride. So yeah, that's more about the question. We'll go jump to the solution and try to code it out. Thank you. We notice that there are two parties. One is Democrat and Republicans. So we will be creating two integer variables in order for us to maintain a different combination of them, such that we'll know that, okay, these combination exist in a certain override. Now, we are going to also use a cyclic barrier. The reason for that is a capacity of each override is 4, or whatever the user is providing. So the reason why we are using cyclic barrier is that at a certain point, we need to make sure that 4 threads are available, or 4 analogy of the thread is basically the Republican or the Democrat. So 4 of them are available in order to get into a cab and move on to their destination. Another thing that we'll be using is the return clock in order to protect the shared variables, which is Democrat and Republicans. And we have two different methods. One is a seat Democrat and seat Republican. So whenever a Democrat is coming, he's going to call the seat Democrat. Similarly, whenever a Republican is coming, he's going to call a seat Republican. So this is the top level structure. But one thing that is missing from the top level structure is we can't simply rely on a cyclic barrier in order to restrict or to adhere to the restrictions whatever is provided in the question, which was basically that a certain combination like 4 Republicans or 4 Democrats, or 2 Democrat and 2 Republicans can go together, right? But cyclic barrier does not guarantees that. What happen if one Democrat is already waiting and 3 Republicans come? Cyclic barrier is only going to see that, okay, 4 threads are already waiting, I'm good to go and I'll go ahead. In that case, fight can occur, right? So in order to avoid that, we are going to use semaphores with initial capacity of 0 to differentiate between a waiting Republicans and a waiting Democrat. And we'll understand it better, the usage of it, once I do the code walkthrough. So let's imagine that first thread come, and that is a Democrat is calling it. So what is going to happen is a Democrat has already called. We are going to acquire a lock. Democrat increment is going to happen such that we'll know how many Democrats are waiting. Now, this condition is not going to satisfy, as these two condition is not as satisfying. Similarly, a Democrat equal 4, this is also not satisfying. We'll simply go to unlock the lock, whatever we have, and we are going to acquire a semaphore. As we have set the initial capacity of semaphore as 0, so it is not going to move forward, as it is going to wait for a semaphore to allow a permit. So my first thread is going to wait at line number 46. Similarly, we are going to have another thread that is going to come and post that 3 or 4 more threads. So once I have Democrat equal to 4, what I'm going to do is my current thread, including my current thread, there are totally 4 Democrats that are waiting. So what I'm going to do is I'm going to release the permit such that all the threads who are waiting for a permit over here are going to get released and going to move ahead with the next code of execution. So now what I'm going to do now is I have 4 Democrats that are there, and I'm simply subtracting, as I'm going to send all of the Democrats in the same cab. So I'm going to call a simple dummy seated method, and over here I'm going to wait for all the 4 Democrats, or it can be Democrat and Republican, right, based on the above condition, if above condition would have been satisfied. Once we have all the Democrat and Republican, all the combination, then I'm going to see that, okay, do we have any ride leader or not? The reason for that, why we are checking this, is ride leader we are only setting once we have a valid combination. And once we have a valid combination, we should be able to tell the driver that, okay, let's go. We have a valid combination and we can go ahead. No fight is going to occur. And post that, as this is an else block, we want to make sure that lock is always released. So post that we are releasing the lock. And that's how the code is going to go through, and I'm going to also execute it and show you how the flow actually works and what should be the output in this case. Similarly, seat Republicans is also going to look similar like this. So I'll jump straight to my main method, where I have written some test cases The test cases is looking simple. This is basically a seat Democrat. You're calling it 10 times. Similarly, 14 times I'm calling seat Republicans, and I'm starting and waiting for them to join. Right. So let's run and see the uh, output. Okay. So if you see the output, as you can see, all the Republicans. This is a valid scenario. All Democrats are together. Two Republican and two Democrat are together. Then in this case also it is valid. It is also valid. So yeah, we are able to achieve whatever task has been given to us in the problem. Thank you.